If you have ever wondered why the tide goes in and out, now is when you get to find out. This is the old swimming pool at Wembury Point with the tide out. We call that low water. This is the same place, half tide, and this is high water. The changing tides are all down to the Earth, the Sun and the Moon and how their positions change. Here's a map of the world. North at the top, south at the bottom. West on the left, west almost rhymes with left, and east on the right. And you can remember north, east, south, west by remembering never eat shredded wheat. The points in between also get names. Northeast, southeast, southwest and northwest. And the points in between these also get names. But it is easier to remember numbers, so we use the 360 degrees of a circle for directions other than the big 4 or the big 8. Now the world spins round to the east, making it look like the sun and moon move to the west. Here's the sun rising to the east over Wembury Bay, and here it is setting in the west. In this time lapse, you can see the sun moving from the left in the morning to the right in the evening. And the moon rises in the east too. Notice that it's just a crescent, like a nail clipping, and it sets in the west. Notice this time it's a complete circle. And here the moon is halfway between the crescent and the circle. I'll explain how that happens in a minute. But you do also notice that the moon and the sun appear to be the same size. The sun is really much, much, much bigger than the moon. This video shows how distance can make things of different sizes look the same. While we go round the sun, the moon goes round us. The Earth is bigger than the moon and smaller than the sun, but the sizes and distances are not shown accurately here. The moon is only 250,000 miles away, while the sun is 93 million miles away. The sun shines on the surface of the moon nearest to it, so when the moon lies between us and the sun, you can't see the lit part. When the moon has gone a quarter way round us, we can see half of the moon lit by the sun. Halfway round and we can see the whole lit surface. 3/4 round, just half again, and back to the beginning. So on day 1, we have a new moon. On day 8, the first quarter, the full moon happens on day 15, and the third quarter happens on day 22. And back to the new moon 28 days later on day 29. By moving the torch around the golf ball, we can see how the aspect of the lit part of the moon changes. Now we have to add gravity to the mix. Although the moon has less mass than the sun, it is so much closer that its gravitational force on the Earth is stronger than that of the sun, shown by the double-ended arrows. As the Earth itself doesn't stretch much, it stays round. But as we have a global ocean, it is free to move in response to the pull of gravity of the sun and moon. When they both line up, it stretches more towards and directly away from them. When they pull at right angles, the pull is not so strong in one direction, so the ocean is pulled less far away from being round. Back to pulling in the same plane, and the ocean makes 2 big bulges again. Right angles again, less of a bulge, but still pointing towards and away from the moon. Where we have 2 big bulges, and because the Earth is spinning around inside the ocean, we have 2 high waters and 2 low waters a day. 2 small bulges, so 2 not so high waters and 2 not so low waters. 2 big bulges, 2 high waters and 2 low waters. 2 small bulges, 2 not so high waters and 2 not so low waters on neap tides. Now you can tell me which day is this And are the tides springs or neaps? And here's the answer. And again, what day is this? And are the tides springs or neaps? And here we are, neaps on day 8. And the next one, are they springs or neaps? And what day? Spring tides on day 15, and that's the full moon. And this one, so third quarter, neap tides, day 22. And last of all, we're back to spring tides, day 29, and a new moon. So now you know that the level of the water goes up, and the bridge across the marina is horizontal, and it goes down twice a day, and you can see all the bridges pointing down at an angle. It also goes in and out, floods and ebbs. You can see the tidal stream roaring past this buoy, held in place by a chain. But to complicate things, it changes each day. Fortunately, the times and the depths can be predicted. And why is this? The Earth spins round once in 24 hours, and as you now know, the Moon takes 28 days to go round the Earth. So if you do the maths, you find that the Moon should rise about 50 minutes later each day, and the times of the tides will change by about the same amount. And you may wonder why we bother about all this. So what, you say? So just from my experience, one of the reasons it's important to me is because I keep my boat here in Mayflower Marina, which is up the Tamar a bit near the Kreml Ferry, just above the Narrows, where the tidal stream is very fast when the tide goes in or out. Because of the 28-day cycle, the times of high and low water springs are about the same time of the day each time. When the moon is full or new, low water is within a few minutes of midnight, and the next one around midday. So during spring tides, we go out into Plymouth Sound in the morning, going with the ebb, play around in the Sound, maybe find some dolphins, and return when the tide turns and come back upriver with the flood. On neap tides, we go upriver with the flood, see the bridges and the ships, and when the tide turns, come back with the ebb. That way we never have to go against the tide, and we can go further and see more. And this is the River Yelm, with a mud bank just outside the main channel there. But and I ran a friend's boat aground there last year. But I knew the tide was flooding, and all I had to do was to wait a couple of minutes, and we floated off. If the tide had been ebbing, we could have been on the mud all day, but I would not have been outside the channel trying to get into less tidal stream. Low water also matters to me for rock pooling and snorkeling on cat shark egg cases, and I'll tell you about those later. Now it's time for you to put your thinking heads on again. And can you think of other reasons why knowing about tides is important for people? And why wildlife might need to know about the tides? Now here's a few I've thought of. Before SatNav, if you couldn't tell where you were by looking at the land, you could tell how far you had gone through the water, and the compass would tell you what direction you'd been pointing. But you had to know how fast and in what direction the tidal stream was going to know how you were moving over the ground, and thus where you were. Some harbours have a shallow bar across the entrance, and you don't want to try and get in or out when there's not enough water to float your boat. Remember I said that in Plymouth, low water springs is around the middle of the day, night or day, and high water then is in the morning or evening, which is just when there's lots of traffic going to work. If there's been a very high tide and the barometer's low, lifting the level of the water, and the wind's been blowing from the southwest, piling it up, and there's been a lot of rain, and all these things tend to happen at the same time, the road near Lara Bridge gets flooded and the traffic stops. As sea level rises due to climate change, this will happen more often and in more places. Renewable energy is getting more important with climate change, and the tides provide predictable energy, not necessarily when it's needed, but predictable. And it always happens, either by putting turbines in the water to harness the tidal stream, or by holding the tide back with a dam and letting the water out through turbines set in the dam, as in the Rance here in France. And as far as animals go, there is a theory that having evolved in the sea, primitive animals were able to colonize the land because they had already developed some means of getting around by having to cope with rock pools when the tide goes out. So no tides, no life on land. Well, maybe. The tidal stream brings food to some animals, and for wading birds, low water reveals mud full of yummy worms, snails, crabs, and stuff like that. Some species time their mating around the tides. On the same tide each year, all of them release sperm and eggs, which provides food for other animals, and they even do it in a lab thousands of miles away from home. Animals that hunt up estuaries need to know when to get back to sea to avoid being left high and dry. And sandhoppers, tiny little insect-like things, live in holes in the sand above the high water line, these little black dots. But they forage down the beach when the tide is out, so they have to work out when to get back home twice a day, in spite of the times changing irregularly. And here we are back at Wembury Point, and you can now appreciate why there are lines of seaweed on the beach. As the tide was going from springs to neaps, each high water was lower than the last one, so the strand lines here, which is where the sea leaves things that get washed up while the tide is in, have moved down the beach. And on a high note, thank you.